It just remains for me to have the great pleasure to introduce our speaker today, which will be Dr. Lucy Havens, who's a researcher, a data scientist, and a designer whose work bridges the physical and digital worlds. Dr. Haven specializes in creating interfaces that make the invisible visible using speculative, data-driven, and human-centered approaches. Her research lies at the intersection of responsible AI, machine learning, and cultural heritage. And she recently earned her Ph.D. from the University of Edinburgh, where she developed a natural language processing approach to uncover gender biases in archival metadata. In this talk, Dr. Havens will share her research on leveraging machine learning to identify gender bias in archival catalogue metadata. And I, for one, am very much looking forward to hearing from Dr. Havens about her experience from AI, especially as she seems to be someone who was clearly working on it long before the rest of us imposters even had heard of ChatGPT or a DeepSeek. So the floor is yours for today, Lucy.
Thank you. Thank you for that introduction. So the title of my talk is Machine Learning Approaches to Gender Bias in Archival Curation. And this work began during my PhD at the University of Edinburgh, where Beatrice Alex, Benjamin Bach, and Melissa Terrace were my supervisors. And I also worked quite closely with Rachel Hosker, who was my main point of contact in the university's archives. I investigated machine learning approaches to managing bias in catalog metadata descriptions, creating the first text classification models to identify gender bias language in a GLAM catalog. And now, thanks to a research and innovation grant from the National Archives, I've been building on that work with Ian Johnson and the Newcastle University Special Collections team. Most of the work I'll talk about today is based on research I've been doing at Edinburgh, as the work with Newcastle is still in progress. I'll provide an overview of the models and my approach to their development and evaluation, discuss insights that this research offers on the capabilities and limitations of machine learning for description and critical cataloging workflows. And then I'll close with recommendations for machine learning and artificial intelligence working to address bias and its harmful consequences, as well as recommendations specifically for the GLAM community when thinking about applying these technologies. So my research was motivated by limitations to approaches to bias in both galleries, libraries, archives, and museums, and machine learning and related fields. So this includes AI, natural language processing, computer vision, et cetera. I'll start by talking about the GLAM side of things. As I'm sure this audience knows very well, GLAM have increasingly been dedicating resources to a process variously referred to as critical cataloging, conscious editing, anti-oppressive description, and collection reviews. The aim of this work is to review existing catalog descriptions for socially biased language that misrepresents or omits information about the past. Collection items, professional and institution-specific practices and training, time, metadata standards, classification schemes, controlled vocabularies. These all influence how collections are recorded in catalogs, including any misrepresentations and omissions that get written into their metadata descriptions. By misrepresentation, I mean information that might be inaccurate or stereotypical, sometimes including the presence of terminology that today we consider derogatory, although it may have been more commonly used at the time that the collection material was created or the description was written. But it can also include more subtle, kind of nuanced biases, such as describing women in relation to the men in their life, whether it's a husband, a father, a son, rather than a person in their own right. And by omissions, I mean silences or exclusions. For example, how enslaved peoples were often not named or acknowledged in records of their labor, or how married women have often been referred to by the title Mrs., followed by their husband's name rather than their own name. The work of revisiting existing catalog descriptions to add context and present-day terminology or to correct inaccuracies has to be balanced with writing new descriptions. And GLAMs are facing a huge backlog of material in need of description. So this made it a compelling use case for machine learning. And while big tech and much of the media are enamored with the advances in large language and computer vision models, they aren't as generalizable as their creators claim them to be. I'll get into more of this later, but for now, suffice it to say that description is, and for the foreseeable future, will continue to be a largely manual task. This is great for ensuring the criticality and quality of descriptions, but it's not particularly efficient. So it doesn't help with that huge backlog of material that hasn't been described yet and thus can't be found by the public. So shifting over to existing work in the machine learning community and some of the limitations with their approaches to bias. The first limitation I identified when I began this research back in 2020 was that machine learning researchers and practitioners generally assume that bias can and should be removed. For some use cases, like content moderation on social media, where you want to prevent hate speech or child pornography from spreading, this makes complete sense. But for other use cases, like information discovery and the GLAM context, this approach doesn't make as much sense. Bias is a characteristic of human society that shouldn't be forgotten because it tells us about the past and how we got to where we are today. It informs efforts that we can make to create more just societies by reminding us where we've gone wrong, what's already been tried and didn't work, and why. So sometimes bias really just needs to be managed and communicated transparently and carefully rather than being removed. Another limitation with existing machine learning approaches to bias that became evident the more I read into the literature in this area was an oversimplified conceptualization of bias. Machine learning and more broadly data and computer science will insist on quantifying everything they can. And there are good reasons for this. Standardized metrics and numeric results make it easy to compare and contrast data sets and models to see what works best. But quantification does have limits. It's difficult to represent uncertainty and complexity when relying solely on quantitative measurement. This has led to only a small variety of biases that end up being explored in existing machine learning work, and in ways that are quite simple relative to how humanities and social science traditions conceptualize bias. I'll give an example of why this kind of intense focus on quantification is a problem. So last year, a paper in Nature written by Hoffman and colleagues was published about racist behaviors that so-called state-of-the-art language models expressed in spite of efforts that those models' creators had undertaken to mitigate their biases. In the paper, the authors divide bias into two types: overt bias and covert bias. With overt bias, the authors refer to models expressing a racist attitude toward a person when presented with text that explicitly states that person's race. With covert bias, the authors refer to models that express a racist attitude toward a person based not on an explicit naming of someone's race, but some other kind of linguistic clues. So in this case, language that was written in African American English dialect rather than standard American English dialect. So, and I should say the authors were working in a US context. The authors found that while existing bias mitigation approaches had reduced the model's overt biases, it seemed that the model's covert biases had actually been amplified. So part of the paper states, our experiments show that these, referring to the covert ratiolinguistic stereotypes, are similar to the archaic human stereotypes about African Americans that existed before the civil rights movement, are even more negative than the most negative experimentally recorded human stereotypes about African Americans. And here they're referring to a study called the Princeton Trilogy that's been run repeatedly in the US, and are both qualitatively and quantitatively different from the previously reported overt racial stereotypes in language models. Now, I understand the distinction that the authors have made here between overt and covert bias, but there are even more nuanced and kind of implicit forms of bias that I was seeing when I was looking at GLAM catalog metadata descriptions. So consider, for example, a subset of a description from a catalog record about a collection of a woman, Dr. Susan Binney Anderson. Part of the biographical and historical description reads, as a young married woman with two small children, Kathleen and Margaret, she found it difficult to keep her medical career going. She twice tried to return to medicine full-time, but this just wasn't to be. Now, there's no derogatory terminology or explicitly stereotypical word choice in the description. However, you could argue that the description is communicating an implicit assumption that the state of being young, married, a woman, and a mother negates the possibility of a medical career. And for the record, she did have a medical career. There are records of her working as a doctor. Patriarchal societal structures during Dr. Anderson's lifetime may have caused the difficulty that she faced, but the description doesn't allow for this. On the other hand, the description also doesn't provide information about Dr. Anderson's husband, who may have found it difficult to keep his medical career going, being young, married, and a father, in which case the difficulty of maintaining a career would be implicitly attributed to the challenges of parenthood. So some people might identify gender bias in this description, while others may not. The thing is, if you were to train a large language model on text where this was the norm, that any career difficulties due to family obligations only appeared in descriptions about women, then the model would only learn to make that gender-specific association. These covert or more kind of implicit types of bias and the uncertainty surrounding them are understudied in machine learning research. And with the growing adoption of generative machine learning models for search, summarization, writing, decision-making, it's of increasing concern. So in my research, I set out to characterize the capabilities and the limitations of machine learning for identifying biased language. I asked, rather than trying to remove bias from machine learning systems, what if we used machine learning to call attention to bias? Since bias is a fairly complex concept, and because my PhD funding was only 3.5 years, I focused specifically on gender bias language rather than trying to encompass all types of bias. There's been a lot of machine learning work on bias that doesn't define it very clearly, which makes it difficult to know what the work was intending to measure or mitigate and how to build upon it. So I began by writing what I hope was a very clear definition of gender bias language, which I state is written or spoken language that creates or reinforces inequitable power relations among people, harming certain people through simplified, dehumanizing, or judgmental words or phrases that restrict their gender identity, and privileging other people through words or phrases that favor their gender identity. Here, you could substitute gender for something else, depending on the type of bias language that you wanted to study. So from there, I began working on the process of creating machine learning models, specifically text classification models or classifiers, to try to automatically and efficiently identify gender bias in a GLAM catalog's metadata descriptions. My research process can broadly be broken down into 3 steps. The first being to annotate a sample of descriptions for gender bias language to create the data set that I needed to train models on. To do the annotation work, I hired 4 PhD students, also at the University of Edinburgh, who had expertise in either gender studies or archives, or both. And they worked with me to label the descriptions from the University of Edinburgh's archival catalog that I'd extracted, which represented about the first 20% of the catalog. This is approximately 12,000 descriptions from across a little over 1,000 different fonts or collections, totaling about 24,500 sentences and 400,000 words. In total, the hired annotators and I spent about 400 hours labeling the data. To guide our data labeling, I had created a taxonomy of 11 different labels with definitions and examples to illustrate how each label was intended to be applied. In the taxonomy, I included labels for both gendered language and gender bias language. By gendered language, I mean grammatically and lexically gendered terms such as he, mother, Mr., and queen. Although there's nothing inherently biased about using these terms, I thought that measuring their occurrences across an entire catalog could provide an indication of the representation of different gender groups in catalogs and collections. And you could track that over time as collections grow or as catalog descriptions are revisited and revised. By gender bias language, I mean language that explicitly communicates a bias according to the definition I read out previously. So harming and privileging people based on their gender identity, whether that be a real or perceived gender identity. The 2 types of gender bias I focused on are stereotype and omission. By stereotype, I mean a type of misrepresentation that uses language that's overly simplified or restrictive, unfairly or unjustifiably limiting the possibilities of who a person is or was and what they could achieve based on societal gender expectations. A type of misrepresentation that was out of scope for this work was an inaccuracy. So thinking about a description that doesn't actually reflect the information that is in collection material. And that could be due to just time constraints, or it could be due to language barriers, a number of factors. But for my research, I was just working with the descriptions. I didn't spend a lot of time with actual material that was described. So the other type of bias language I was focusing on was omission, sometimes referred to as silence or exclusion. And this is language that omits a person's identity or information about that person's historical contributions. Once the annotators and I had finished labeling the sample of archival catalog metadata descriptions, I aggregated the 5 individual annotated data sets that we'd produced together to create a single aggregated data set that I could use to create classification models. So that data set was my training data set. To aggregate the data sets, I used annotation instructions that all the annotators had followed to determine whether a label had been applied correctly or incorrectly. For some of the labels, like gendered pronoun, this was pretty straightforward, but for other labels, not so much. And when it came to the gender bias language labels, omission and stereotype, I ended up reviewing all of these manually and deciding to keep all of them, even though there was fairly low overlap across all 5 annotators on the text that they had labeled. I found that some of the annotators just seemed to be more attuned to certain types of gender bias than others, or had interpreted the language slightly differently than others. And given the subjectivity of language and bias, I thought it was better to include all these interpretations rather than choosing to deem some right and others wrong. The final aggregated data set, which became my training data set, had a little bit over 55,000 labels in it. So from there, I could move on to actually training machine learning models. I created 3 types of text classifiers with different subsets of the labels that had been used to manually annotate the descriptions. And then I combined these models sequentially in different ways to experiment with how to most effectively classify the omission and stereotype labels. So those 2 labels really were my focus to better understand gender bias language. I'll be happy to provide more detail about the models if people have questions about them, but there were a lot of different experiments that I ran. So for time reasons, I'll just emphasize one aspect of their design during this talk. I chose to use classical or traditional machine learning rather than deep learning to create the models because I wanted to study gender biases specifically from the University of Edinburgh's archival catalogues descriptions. And using deep learning models would have made this more difficult because state-of-the-art deep learning models are incredibly expensive to train. So people have been making pre-trained versions of them available. You might have also heard these models referred to as foundation or frontier models. This is okay for some use cases, but the problem for my research was that these models will have learned gender biases from their pre-training data set. And even if I customize the models on this new data set that I'd created, the influence of the pre-training data set would still be there. And there isn't currently a way that we know of to differentiate between biases a model learns from its pre-training data set versus data used to customize the model. This is a phenomenon commonly referred to as bias injection. And existing research has shown that efforts to remove bias from models during pre-training to prevent this sort of bias injection haven't actually been successful in doing so when those models are trained further on a custom data set. So I trained classical machine learning models in a supervised learning setup, meaning the text classifiers were only trained on the aggregated data set of manually annotated descriptions from the University of Edinburgh's archives catalog. The last step was to evaluate the classifiers. To evaluate how well machine learning models perform, as you may surmise, quantitative metrics rule the day. Bucking that trend, though, I used a mixed methods approach, complementing these typical quantitative performance evaluation approaches with a qualitative evaluation, running a workshop with information and heritage professionals to gauge their opinion of the model's value for their workflows. This sort of mixed methods approach is common in the field of human-computer interaction, or HCI, because quantitative and qualitative methods have distinct advantages and disadvantages. So combining both is a way to combat that. I'll start by showing the quantitative results. I used typical quantitative metrics in machine learning, specifically natural language processing or NLP work, which are precision, recall, and F1 score. These are all based on true positive, false positive, and false negative counts, meaning the correct classifications, the incorrect classifications, and the missed classifications. So true positive, I've abbreviated TP, false positive FP, and false negative FN. Precision measures how many correct classifications a model actually made out of all the classifications it should have made. excuse me, reverse that, recall measures out of everything that should have been classified, how many were, precision measures out of every classification, how many were correct. And then F1 score combines these into a single metric by taking the harmonic mean of precision and recall. And with each of these metrics, the closer a score is to 1 or 100%, the better. As I stated earlier, I'm focused specifically on omission and stereotype. And so I'm just going to present results for that in this talk. The table here shows F1 scores per label with omission in the top and stereotype in the bottom row. This IA column refers to the inter-annotator agreement amongst the 5 human annotators that labeled the data. And you can see this is rather low, 0.4. And again, that's part of my motivation, had been my motivation to simply aggregate all the labels, because I felt that all of the classification or all the annotations that manual annotators were making were correct. It was just that they were more attuned to different variations of gender bias. And then this column here is showing you the average of each individual annotator's agreement with the training data set. And by agreement, I mean essentially the overlap in their labels. On the right, you have the F1 scores for 4 variations of text classifiers that I trained to automatically annotate descriptions as having an omission, a stereotype, or both. As I mentioned, this is a fairly low IAA score here, which is an indication that the task is very difficult. The omission score of the annotators relative to the training data set is the highest relative to all the classification models. Whereas with stereotype, the classification models actually performed better than the manual annotators did. And that's more the result that you hope for. So these results indicate essentially okay performance, but there's definitely room for improvement. And I'm now working with Newcastle University Special Collections to continue refining these models, running them on a different data set of descriptions from archival collections at Newcastle, and conducting analysis to better understand where the models are working well and what they're not so good at, so I can run more experiments to improve them. Now I'll move on to the qualitative results. To run a qualitative, more human-centered evaluation of the classifiers and their training data, I conducted a workshop with 10 librarians, archivists, and curators who were working at the University of Edinburgh's Heritage Collections department while I was there. I ran the workshop like a semi-structured interview, providing a few questions for each 1-hour activity. There were 2 activities total, which helped kind of prompt and guide, but not restrict the participants' discussion. To give participants a sense of what the models were doing, I gave them all worksheets with different outputs from the models, providing a close reading and high-level view. This is an example of a close reading view where I provided 3 example descriptions from Edinburgh's archival catalogue, and the colored boxes are indicating the different ways that the classification models would label or classify the text. And I told participants to feel free to make notes on the worksheet so that I could use those to refer back to, in addition to the discussion when I was doing the analysis at the end of my research. So that's what you see with all the notes there. And then I also, for the more distant views, provided a worksheet that showed tables listing the font or collections that had the highest counts of omission and stereotype labels, and charts that visualized quantities of select labels and the performance of one of the models. So here we're seeing the count of the omission and stereotype labels, as well as the count of descriptions that had both. Here, gendered pronoun, gendered role, and generalization labels. And then this bottom chart is the one that's looking at the performance of the model that did these classifications, showing the true positives, false negatives, and true negatives. The workshop lasted 2 hours, and with participants' permission, I had audio recorded the discussion. So I created a transcript of that and used that along with the notes on the worksheets to analyze the observations and recurring themes that came out of the workshop. I took a lens to that analysis that was kind of focused really on the complexities and uncertainties surrounding bias and the power relationships at play in GLAM description workflows. I'll talk through just 3 of the observations now, but you can see my thesis and another forthcoming paper that will be published at the CHI conference this spring if you would like a fuller list of all the observations from the workshop. So one observation is about a label that I haven't talked about so far, the occupation label. A participant observed gender bias in how this label was applied. Its application actually reinforced the gender bias that I had intended it to push back against. A participant pointed out that because the label was only applied to job titles, as I had instructed annotators to do and then trained the models to imitate, it didn't account for the ways in which women had worked during times that they were facing a lot of barriers to entering the workforce and barriers to holding positions that would have given them a formal job title. Florence Jewell Bailey, for example, in one of the archival collections, was described as having written a foreword for her husband John Bailey's book and attending meetings with her husband. When I looked at the material in the archival collection for that collection, I saw that she wrote about her own work and office in her journals, and even recounted an instance in which she was told that a man did not wish to take orders from her. So there were hints of Florence Jewell Bailey working in the metadata descriptions, but they ended up not being annotated with an occupation label because she was never described with a job title. Another observation that came out of the workshop is about the challenge participants said they face when trying to balance the interests of different communities of people, because sometimes one community's preference conflicts with another's. As an example, a participant talked about a catalog record in which someone described themselves as a Highland traveler, which is today not considered the appropriate term. And this participant said that a present-day member of that community had contacted the University of Edinburgh Heritage Collections to request that the description be changed to use today's accepted term, Gypsy Roma traveler. The challenge this poses, in the participant's own words, is, well, whose say is it? Is it the current community, or is it the person whose own voice it is? This complexity is echoed in findings from Diaz-Olivier and colleagues' research on machine learning for content moderation, which has found that approaches to identifying and removing hate speech also often end up silencing LGBTQ voices when people are posting empowering things on social media that definitely isn't hate speech. The third observation I'll mention is the sense of responsibility that participants felt to past, present, and future stakeholders. And this, to me, is in stark contrast to the discourse that you see in machine learning and AI publications. Workshop participants talked explicitly about this responsibility and the difficulties and concerns that it posed for them. When they were talking about critical cataloging and description work, one of the participants said, "I think it's socially really important because so many people are going to look the catalog up, students, members of the public, and refer to that as a kind of non-biased factual resource. So it's different from writing something where you assess your positionality and make that clear to the reader. It's a big responsibility to get right as well." Extrapolating from these and other observations, there were 4 ways I found that participants identified machine learning being useful to their workflows, including but not limited to critical cataloging. So first, by supporting critical cataloging with estimates of the quantities of potentially biased descriptions per collection, and in this way being able to inform the prioritization of collections and collection descriptions to review. Informing improvements to description practices was another area of value to better avoid perpetuating social biases while also staying true to the contents of GLAM collections, because sometimes the models were identifying things that the participants didn't disagree with, but they hadn't previously thought about a description in that way before. So it was kind of expanding the way that they thought about gender bias and biased language. And thirdly, providing evidence of resource needs for cataloging work, including both critical cataloging and writing new descriptions by being able to point to a large number of collections in need of review. And then the last area of value that participants talked about was the way that this whole exercise encouraged critical reflection, kind of guided their continuous improvement, both for their specific GLAM institution, but also for the entire profession. However, participants did emphasize a reluctance to rely too much on machine learning and AI. They saw machine learning as supporting and enhancing their work, not replacing it. And they wanted the opportunity to pick collection descriptions for themselves for the models to classify so they could further study and evaluate how the models worked and how they were interpreting language. Participants attributed this attitude and kind of skepticism toward the nature of bias, which they characterized as contextual. So it's a result of complex interactions between cultural, historical, political, economic, and social events, relationships, and practices, all of which are constantly evolving as time passes. They characterize bias as dynamic, meaning approaches to bias are not generalizable across all communities, as I gave an example with the use of the term Highland traveler and different attitudes historically and present day towards that term. And data bias is inevitable in many instances because the choice of what data to collect and not to collect and how to interpret that collected data are processes that privilege certain perspectives at the expense of others. And as I explained with the application of the occupation label, I had engaged in all this work to try to push back against gender bias, but ended up in some ways actually reinforcing that bias. So what does this mean for machine learning approaches to bias? And more specifically, what does this mean for applications of machine learning and AI to GLAM? For machine learning and AI, broadly speaking, the qualitative results of the work reinforce the importance of using human-centered research methods when applying machine learning and AI approaches to bias and fairness. Rather than working towards universal and widely generalizable models, the contextual and dynamic nature of bias calls for more situated, specialized models that are designed for more narrow use cases. If you ask me, AGI, or artificial general intelligence, is really not what we should be aiming for. This work also calls for machine learning researchers and practitioners to start from a different question. Before asking, how can we remove bias? I argue that we should be asking, can we remove bias? And if so, how comprehensively? To what extent? And if not, how can we mitigate its harmful consequences rather than mitigating bias itself? For applications of machine learning to GLAM, 3 questions that I suggest considering are, what do we know is missing from our collections or from wider cultural and historical narratives? What has been overlooked and misrepresented? Following along with that, are there hints in the word choice or structure of our catalog descriptions that we can use to locate those omissions and misrepresentations? Will the machine learning model we're using be able to pick up on those hints? Can we customize the model to do so? And lastly, when using machine learning to identify biases in existing descriptions, it's important to consider the different ways that bias manifests. So lastly, we want to be asking, why do we want to identify bias? Are we trying to understand how descriptions alone have encoded social biases, or do we also want to understand how our collections reflect social biases? The reason I make this distinction is that bias can manifest in GLAM catalog descriptions in several different ways. How something is described is in the word choice, terminology, the detail that's included and excluded about a description, and reflecting bias that's in a collection item. So if a woman was only identified as Mrs. plus her husband's name, and that information about her own name isn't available, then that's what will go in the catalog record. There are also ways that descriptions have been written to push back against social biases. So I wanted to go through a couple examples before I close to provide some more concrete ideas of what I mean here. So there's a description in the Edinburgh Archival Catalogue that reads, although Yolande Sonnabend shared the copyright of this book with Waddington, she was not credited as an illustrator. Now, the question is, should this be labeled as gender biased? Because the description itself is calling attention to the fact that there seems to be, or potentially is, a gender bias here. But it's not due to any inaccuracy or assumption relative to the collection material itself. And that's in contrast to a different description in the same catalog that reads, Jewel took an active interest in her husband's work, accompanying him when he traveled, sitting on charitable committees, looking after missionary furlough houses, and much more. She also wrote a preface to his baptism and conversion and a foreword to his A Reasoned Faith. Now, I actually took a look at the collection material of the jewel referenced in this description, and I can tell you that she talks about her own work and going to an office. And so here, after looking at the material, it seems that characterizing Jewel as having taken an active interest in her husband's work isn't totally accurate. And it feels more like a bias that's coming from the description itself rather than something that's reflected in the collection material. Because there was nothing in the collection that made it seem like Jewel couldn't have shared interest with her husband's or even influenced her husband's work. So in conclusion, machine learning is definitely useful, but it must be applied critically in order to perpetuate and in order to avoid perpetuating and amplifying the types of biases that the GLAM community has been making so much progress to address. We're all subject to the influence of the society that we live in. So this work isn't about blaming anyone. It's about finding a better way to manage bias and to take a data-driven approach to that management. Before taking comments and questions, I'd just like to thank the UKRI Engineering and Physical Sciences Research Council and the Informatics Graduate School at the University of Edinburgh as the organizations that funded my PhD research, as well as the National Archives, which awarded Ian Johnson and I a research and innovation grant to continue this work with Newcastle University Special Collections. That work will be coming to a close in May, and the plan is to have one, maybe two publications and a tutorial about using the models coming out of that. I'll also be at the DCD conference over the summer, so maybe I'll see some of you there. But I wanted to say that I would love to continue this research. So if you're interested in collaborating, please feel free to reach out. It's looking like funding this sort of work in the US is going to be rather difficult over the next few years. Thank you.
Well, thank you, Lucy, for that fascinating paper and quite technical approach, actually, from everything you laid out, and really fascinating that it's come alongside these sort of bigger systems and the more popularization of AI, out of the winter into the summer. I have quite a lot of questions, but I guess the first one just comes from an immediate thing. I was at an event with ProQuest, and they were showing their kind of new archival system, which will do automatic metadata generation and all of that type of stuff. And they're very into selling that product. And I was very curious about what you were, kind of reflecting there about the necessity to, have very specific models. And I just wondered if you could maybe speak to that concern that we're all getting kind of caught up in this commercial AI, and what's the risk of just jumping into this without suitable studies like your own, and what kind of biases can we expect if we just go into that?
Yeah, thank you. So that's where I think it very much depends on what the description is aiming for. So if you're trying to recognize, the type of material, is it a letter? Is it a photograph? That's where I think, it can be great. And if there's, or if there are books with titles and dates or manuscripts with titles and dates that can be recognized, then that's a great use case. What starts to worry me more is actually summarizing the contents of the material. Because I think that's where, when I was talking about the kind of covert versus overt bias, it just really hasn't been explored very deeply so far. And so I'm a little bit nervous, given kind of existing studies I've seen as well that have used ChatGPT, for example, to produce stories, and finding that there are, definitely stereotypes being written into those stories. I think that we risk potentially just in like growing the problem that we're trying to address with critical cataloging. So it's like you're solving one problem, but you're also just making another problem bigger. And so that's where, yeah, it's like I think it's great because there is such a big backlog to apply this material, but it just needs to be applied in a way that isn't trying to do that really difficult and complex contextualizing work.
That makes a lot of sense. And with the kind of generated descriptions as you talk about, I mean, I guess my fear there is when we start to use those in embeddings, that they just go straight into the search part. Because from your paper, it seemed to be, and tell me if I'm wrong here, kind of looking at how it's read rather than how it's searched. But maybe this is outside of your area. But what consequences are there for these biases if we are embedding them? So if we're does policeman embed the same as policewoman? And when we search for it, does it do something differently with how the results come up?
Yeah, and it definitely does. And I think that's where, when I was talking about bias injection, when there has been research there's actually word embeddings are a really popular way to try to approach what I think is a misnomer, but is sometimes referred to as debiasing work or trying to balance out data sets, is starting from the word embeddings. But people have looked at analyzing that in different ways and kind of saying, okay, so we did this approach to try to debias, but now if we're going to apply those embeddings to a model and then to a later task like search, did that process of trying to balance out the data actually work? And there have been really mixed results, with a lot of it finding that it actually just kind of hides the bias and makes it a little bit harder to pick up on, but it doesn't take it away. So yeah, so that's exactly a use case um, that would concern me, because I think that it just scales up that problem of social bias in data.
No, that it's so interesting, and I'm a historian by training, and we'd always encounter 19th century archival descriptions a lot because that's who wrote those catalogs. And it seems
Yeah.
to me, from what you're saying, we're just going to fix a point, early 21st century biases, and that's going to be kind of spread across all of our catalogs if we go in with the bigger models. So, no,
Yeah,
really
yeah.
interesting.
And there's been some work coming out of the Living with Machines project with the British Library and Alan Turing Institute that was looking at the kind of influence of time and starting to try to experiment with how to customize models for language of specific time periods. So I think it's a super interesting area, but again, we're only at the early stages. So yeah, it's definitely something that needs to be explored more.
Well, I will turn now to the Q&A, and just a reminder to everyone, if you have any questions, please drop them in there. The first question through is, could you further elaborate on how the annotators annotated differently? I think this maybe came up when you were having the individuals annotate themselves. Would it also be a non-agreement if one annotator chose the same passage as another one, but missing, e.g., one word, but both giving the same label? Or what exactly classifies as non-agreement?
Yeah, good question. So I evaluated kind of both ways, but ended up going with what's considered more a loose agreement. So if there is overlap, even if it was one word that was off, I considered that to be correct. Because for the most part, I wasn't really interested in like individual words. I was looking more at kind of the larger description and how bias was coming through. In terms of the disagreements, the biggest disagreements were around how people's names were labeled. So I kind of, coming from having read a lot of work in like gender studies and feminist and queer theorizing, was worried about misgendering and kind of assuming too much about someone's gender based off their name or their occupation or the grammatical or lexical gender of terms that referred to them. So the way I had written the instructions for annotation was to say, within the context of a single description, um, have a person's name labeled as unknown if there's no grammatical or lexically gendered term that's referring to them. And if there is, then give that name whatever that grammatical or lexical gender is. So I had feminine, masculine, and non-binary, although in our data set, non-binary didn't end up being used. So that's a definite gap. And what I found was that ended up being quite difficult because I was working at the individual description level. And if somebody in an earlier description from the same collection had been identified with a masculine or feminine term, then often that name later on would be given the masculine or feminine label instead of unknown. But it was really inconsistent. And it was also kind of, when I was reviewing the data to try to understand the disagreements, it was difficult to know whether assumptions were being made based on a person's job or whether it was based on a previous description, because some of the collections are super lengthy. So just with kind of the interface of the annotation platform, I initially had wanted that description to happen at a collection level rather than an individual description level, but it just was proving really time consuming. So in the interest of trying to create this data set in a shorter period of time, I hadn't done that. But I will say, I think the workshop with information and heritage professionals kind of emphasized the fact that in some instances, actually, a perceived gender is useful because it provides information about how that person would have kind of moved through society at their time. So again, it's like a very different context than looking at like social media and news reporting, because in some ways, a perceived gender can help you understand a person's experience historically, even if that's not how they would describe themselves today. So that was where there were the biggest disagreements.
Great. Well, the questions are coming in thick and fast now. Next one is, I'm curious to hear how you interrogated the intersectional connections between gendered and racist language. I know your focus was on gendered language, but what was the process of separating these intertwined forces within the descriptions you worked with? Uh, and what were the challenges?
Yeah, so I didn't do this a lot, and it was something that in all the papers I've written about this work, my supervisors, we have acknowledged that this is a limitation and something that needs to be explored more. I can say from having done a lot of the manual annotation work, it was definitely something that that I saw. So, for example, as you might imagine, there's a lot of material that has kind of roots in colonial practices. And so the ways that certain people were being described in different countries outside of the UK had a tone sometimes that uh, felt a bit dehumanizing. And it was difficult for me to kind of pinpoint exactly what that was. But you tended to get a lot more unidentified people, and more description about kind of their physical appearance. And so that's something that I am hoping to be able to go back to within the next couple of months, is start to look a little bit more at those linguistic patterns. And I'm thinking from there, I'll be able to start teasing out where there is that kind of intersectional bias occurring, and then yeah, kind of use that to guide future research that does dive into that more, because it's definitely a gap that I would like to address.
Thank you. Okay, so next question is, what is your view of the potential to develop adversarial AIs to be critical of machine learning output as part of the architecture or of producing catalog descriptions for different user groups? Is this the way things will go? The person says that they've already got a colleague looking at how AI can be used to provide descriptions meeting the needs of people who are neurodiverse.
That sounds really cool. I would love if you could send me that if there's anything written up about it to read more. I think it is a great direction. I just am not sure that it can account for everything, because at the end of the day, the process of adversarial machine learning is still relying on humans to identify kind of what's missing. And I think that it's difficult for one person to do that comprehensively. And so if you can incorporate different communities in developing those approaches, I think that will definitely help. I would imagine still though that you will need that kind of community involvement. And again, because things change over time, also it will be a continuous process. And then there's also the fact that sometimes people just disagree. They might be from the same community and they want to be referred to in a different way than somebody else does in that same community. So I think all of these approaches are great. It's just important to recognize that they're not sufficient on their own.
Thank you. Okay, so the next question is, I liked how you posed the question of, can you remove bias? Because it injects a consideration for complicity in addressing these issues instead of operating from a notion of innocence and perfection. The person doesn't know much about AI ML, but they didn't imagine the Silicon Valley tech crowd cared much about eliminating bias at all. So what would you say are the existing methods in which people working in machine learning and AI are seeking to eliminate bias?
Yeah, so adversarial machine learning, which was just mentioned in the last question, is one example. And the idea there is to try to kind of anticipate what, based on the current biases, like what perspectives are missing, and then create synthetic data that kind of balances out those perspectives by showing another view. So that kind of generating data based on what we know is missing, and then using that to further train a model is one way. Another way that is quite common is prompt engineering. And this is kind of like a trial and error where you're essentially, in the same way that you can interact with ChatGPT, the questions or comments that you're making to ChatGPT is essentially a prompt. And so you can do that while you're still kind of in training mode with a model, and teach it to avoid certain, making certain judgments or using certain types of terminology, or providing information about like how to make a bomb, or how to hack into a particular system. So that's a really common way. And I think all of these they definitely are making progress, but it's on those more kind of covert, nuanced forms of bias that aren't being studied as much, that they don't seem to have had as much of an impact on. So I think that what's missing, in my opinion, is a more thoughtful process in the data set curation, and thinking about how to create a data set that's representative of the audience that you want to use the model. And that's where I think kind of starting smaller and then growing after having these more specialized models is a better way to get to something that is more generalizable, rather than trying to create something that's really generalizable and then figure out how, like, where the gaps are. It just doesn't seem like a very directed approach to me. So I think we should be more bottom up than top down, essentially.
Okay. Well, thank you very much. And then I guess final question for me is, I guess it's very general, but where do you see AI going in archives and cultural heritage work over the next decade? From someone who was very much doing their PhD just as it all exploded. What do you think the
Yeah.
future holds for us? Hopefully still jobs. I don't know.
Yeah, I was at the Library of Congress recently, and someone was asking, because they've been doing a lot of experiments with machine learning and AI, and someone was asking about whether there have been concerns that they're seeing or that they feel are justified around losing jobs. And they were saying there's such a huge backlog of things that needs to get done, things that need to get done, that really isn't a concern. And I think it's also important to remember that these models have been trained on data scraped from the internet. They're not trained on catalogs, and they're not trained on collection material. And claims that they are imitating human intelligence are kind of based on pretty limited quantitative metrics. So I would encourage anyone who's worried to actually look at the way that these metrics have been defined and what is leading things to be called state of the art, because it's really not very nuanced. The models essentially they're probabilistic. They learn what the most likely thing, most likely word, most likely pixel, whatever form it is, audio should come next. They're not reasoning about context or the relationship between two different people speaking. So I think that the GLAM sector, because it's approaching the technology a lot more critically, I actually think and I'm hopeful that they'll become more leaders in this space in creating models that have a more narrow context, but because of that, really actually succeed in mitigating the risk of using these models, and creating them in a way that is enhancing work by automating some of the more boring things of is this a letter, is this a photograph, and opening up more time for people to do the contextualizing work. And so maybe in the future we'll have more time for someone who's cataloging something to actually do some archive or some historical research to understand the context in which material was created within, even if that information isn't explicitly in the material itself. And I think then that can just improve the way that people can discover the information. You can have more enhanced and detailed metadata. So that's where I'm thinking it will be going.